Okay, so we're going to focus in terms of getting our information all from here. So, like I said, we'll download a couple. The workflow is pretty streamlined once you get one figured out. So then it's just a matter of bringing them into Rhino and giving them their height fields. So what you want to do is download, let's say, because we're just going to look at annual change, so to speak. I think so, right? Or do we want to? Yeah, you don't want to look at the monthly. That's going to just.
Probably do each year.
Okay.
Or every other year.
Okay, let's do it. So we'll start off with 2016. I'm just going to create a folder and start dumping all of these in. So we'll do Prism. So what's nice, at least they're all labeled. So there's 2016. These actually download pretty quick. So if you just do the download data, let's make sure that's the right one. That might be it. Oh, perfect. Oh, and this actually comes in like a grayscale map. Okay, so yeah, you just have to actually download this download data.bil.
Would it be important, you think, to focus on this? I mean, if we were doing the same, that has to be up to January.
No, this is doing an annual one. Oh, are you saying when you want to, if you want to focus on a month?
Oh, okay, no, very
Yeah, but no. So this is, like I said, just the annual one. So this helps us just understand like our annual precipitation trend. And then what you have to do then, if you want to like go in detail for like the monthly, then you would just download. You can still keep with the annual ones, but if you do download all data for a year, that'll actually give you the monthly ones. So let's just, okay, so let's do 2014. $2012. And we'll like, with the changes that we make, we'll verify if it's actually retaining that information or keeping it accurate. Wow, you can see 2008 is extremely dry in most areas. That must be when La Nina hit. All right, so that's 10 years worth. That should be good for now. And let's just go ahead and extract all those files. So we can just kind of. Because the one thing that's unfortunate with this is that I want to say the values get converted to metric and Celsius for temperature. So you have to do a little bit of file conversion, but it's not too bad. And it's very similar to like how in Rhino we do remapping values. And I'll explain that too once we actually get there. Okay, so I've extracted all those files. I can get rid of the zipped files. Like I said, we're just going to start off with, we don't really need this one. I'm just going to remove that. Remove that. Okay, so we have our first one. This is 2016. So I can even just rename these to help. So Precip 2016. So once you load that into QGIS, you want to go back over to the Prism website and change it back to 2016 just to make sure what we do to it is still going to look the same or very similar. So this is obviously showing annual precipitation in inches, but like I said, for whatever reason, when it gets brought in, it does get changed. So you can see with that image that there's a highlighted in black 156, and then in gray or in white 1969. That's the precipitation values, which is clearly not in inches. So let's just verify that. So like the high is 1969. Let's see if there's any, looks like there's this really light pink up here. So we know that we have our high value, right? So let's convert that. So it's saying over 160. So let's try millimeters, inches, or vice versa. So 160 inches, oops, that equals like 4,000. So maybe it is centimeters. Nope. Huh. Right. So I know that it's like in this one, oops, that I have like in some areas 160 inches of rainfall, like up there. Is that how I'm reading it, right? Like that's ridiculous that they get that much rainfall, but they do. So I'm trying to understand what this value is of 1969. Like what is 100 or what's 1969 read as? 77 inches? That's nowhere close. Because 77 is reading as just like this blue, and there's definitely that pink. Huh. Let's see what happens if we just go ahead and convert 160 inches to, so we have 4064. So I don't know what this is, but we're going to try and change it anyways. So the minimum we're just going to say is 0 millimeters in this case. And then what is this, 4064? And now we're going to change it from being, let's just give it an actual color. So I'm going to get a single band pseudo color under this render type and just try and pick a color range that I can hopefully see a good amount. And then here's the other important thing you need to know. So for this prism, you have to determine or count the number of values it's looking at. So I can see there's 3, 4, 5 times 4, that there's 20 classifications of rain values. So in QGIS, I'm going to do that same thing where I want to change the mode to equal intervals of 20. Does that make sense? So let's apply that and see how it looks in comparison. See, that's definitely not reading the same. So there's definitely a lot of variation going on. And that's just super blue. Huh. Let's try downloading another one and see what it does. Let's try 2014. That's got 1827 and 121. So those are still really low. I mean, let's just see what happens if I convert that to like 160 and it should say, so why is that not dividing equally? So 0, I guess that's technically. What's the low of the next one? 0, 0 to 4. Huh. Yeah, that's definitely not it either. Huh. I am not sure what's going on with that. I mean, here's the last option. So I remember, I think, having issues with this student before, trying to figure this out. What if we just do it into 20 classifications? That still gives us way too much blue. Let's try 21. Huh. Yeah, it's not changing. I wish they didn't do this terrible file conversion. Yeah, it's not changing anything, which is unfortunate. Let's try just 0. That is odd. And it's getting closer. The other thing we can do with this, let's try. It's weird because the temperature I know works like perfectly with this conversion, but we don't know what that conversion is, and it's never gonna. Oh, this looks better. That's definitely different. But that seems too. I mean, the color values don't have to be the same.
I think that's better.
Yeah, it's definitely better. Right? So,
That little spot very top left.
yeah, exactly, right? Let's, and yeah, like, because I'm trying to look at like what that geometry looks like right there. So that shape with that, that's almost spot on. Okay, so let's run with that one. So we still converted it, so 106 equals 4064. So oops. And we still want to do equal intervals of 20 and then clip out of range. It looks like there's a lot more contrast, but that just could be the color tone.
Yeah, there's only really three different colors.
Yeah. Let's one last thing. I think maybe you have to keep that smaller. So let me just one more time, I promise. Once we get this figured out, it'll be piece of cake. So let's keep that minimum one, but do 4064. We'll do our pseudo color. Oops, let's do 4064. We'll do equal intervals, 20. And we'll clip out of range. So that's just, so it is actually reading, it's just so close of colors. Because it's saying like, because this actually kind of helps confirm it, because you can see what this shape looks like. And that shape right there, that's in the classifications of 0 to 4 inches, I guess. And so because 156 is more than 0, like all those values between 0 and 156 are being clipped out. So that makes sense. So let's actually do, so we are going to keep that. So it is actually accurate, just something about it's just almost too much information. There's a lot more warm colors than there are cool colors, and that's probably why if I did. Yeah, I mean, that's pretty close. So let's just stick with this. So these, like I said, are highest values in our, because and that's the other confirmation, is that this is showing values that are greater than 160, which are greater than 464, so that's why those are being clipped out. So that's fine. So let's just apply it. Okay, so, okay, we've got our first one. This is where we got to convert it to a height field. So we're going to do the grayscale. So we have to go through that whole process again. Except we are going to use the grays. So 0 to 164, equal intervals, 20. We can clip that out because again, like that's such a small area. It's not really affecting us. And there you go. So the way we want to read it is actually if it's, so how do height fields work again in terms of their actual elevation? Are darks high and whites low, or whites low? Say that again? Whites are high, right? So right now we can see the really rainy areas are dark. So we need to invert that first, and now let's try it. So that reads much better. So we can clearly see where that dark range is. And this is where we kind of streamline it for ourselves so we don't have to go through this whole rigorous process for each one of those height fields. What you're going to do is go down to Style and say Save Style. We're going to save this in the same spot as everything else. So I'll color this Precip Style. Hit OK. And now I can just go to this next one. So 2014, double click on it, go down to Style, Load Style, apply. OK. So you can see they are changing. Like it doesn't seem like much, but they are there. It's not like we're just gonna paint them all so the same way. So let's just keep going. So we got to do 12. Again, I'm just gonna, and the reason we're doing that is because in order for this to all match, the low value for this one is reading at 107. The other one had a low value of like 150. So if you were to try and compare that, they haven't been remapped to the same color gradient, right? So they're going to read differently. So that's why we do need to go through this process of just changing or making sure they all have the same matching style. So again, you can see how they're changing. Let's continue. Okay, let's just do one more. Yeah, let's just do this last one. Okay, so we've got 5 ones to go off of. So like before, we can create our map. So that was from the last group. Let's go ahead and just shift this over. So here is the height field we can build off of. Right now it's showing all 5 of them are turned on, but the top one's the only one that's showing, which is fine. The other thing we want to do, so the other thing you need to do to this is to kind of clean up this image a bit. So if I were to bring this into Rhino, it's also going to bring in this giant white profile, which as a height field, it's going to read as extremely high. It's going to read as the top part. And that's going to affect the overall interpolation of our surface. So what we need to do is 2 things, I think. So we want to Page settings, we want to make sure to change our color to black. So that is actually set to black. So it's actually the image that needs to be fixed, which I think so, right? Oh, I'm in the item. So I have to go to my background. So in the composition, you go to page background. What? That's also, I don't believe that. I'm not sure. Let's actually see if it does have a physical white background. It doesn't, so that's weird. So let's try that again. So there's our Earth. So that means, let's turn it back off. So that means our page has to make sure, I don't know why it's, page background. Is it actually applied? Oh, that probably would help. So apply is solid. Now, let's try it. Let's try the item one. There we go. So there was something on. Okay. So we got to make sure that that background is turned off because I guess that was set to white. Perfect. Okay. So now we just got to go through this kind of rigorous process of changing these or saving them. So this is 2008. I'm just going to change this to 200 for now. You can obviously have it a higher resolution for yours, but for the sake of everything else working, then I can just, oops, that was 2014. Alrighty, so let's try it again. So this is now 2016. Oh, really doesn't like it. Okay. You get the idea though, right? Do you want to just move on to like, let's just show one and then you can just go through the process?
Yeah.
Okay. So let's go ahead and create this. So we know these are at, I think 42 by 42. So I'm just going to create a box 42, 42. And now all I have to do is type height field. I'm going to go to that hydrology section and just choose 2016 for now. And so now I can draw my box. And here I'm going to choose some settings. If you just do it like for every foot, so 42 by 42, since it's a 42 by 42, it's fine. The height, this can kind of be left to your discretion, but maybe it's good to use some of that data. So we knew that the max was like 160 inches. So we can just enter 160. It doesn't matter that QGIS is reading it in millimeters. It's all going to get converted fine. And then we want to make sure to interpolate surface through the sample. So make sure that one's selected. Hit OK. It's going to take a second. And there's your crazy profile, which makes sense. Like that's definitely where Washington was. If I look at it in the top, like it's reading fine. It's just there's so much shadow that's kind of interfering with it. But that's okay. You can obviously rescale it down. This just helps you understand better. Like 160 is truly 160 instead of like 160 means 80 elevation. So, okay, so now we can go into Grasshopper. And it's a really simple script, just like the temperature one. There's not a whole lot of changes to it that we're going to make. So I'm just going to create a new one. I'm going to reference this surface. And turn that off. I'm going to do the same thing. I'm going to divide this surface to get a series of points. You can use the points that was made to create it, which is fine, but they do some kind of interpolation, so it's not completely accurate. So in that case, I'm just going to divide the surface by the number of spans I used, which was 42. So I'm actually going to do 43 because it does it into segments. Or sorry, it should be 41. It's 41 segments, which equals 42 points. So it's pretty close. Again, you can always change those values too. So we're going to go ahead and flatten this. And now we can go ahead and go to those points. We probably don't want all this really flat stuff. So let's just filter that out real quick. So let's deconstruct these points. Let's look at all values that are greater than 0.01. That way to make sure we get rid of all that extra stuff. Then we'll do sets, list, dispatch to see which one of those points is actually going to follow that logic. So now you see that those have been cleaned away. And you can always change that if you want to trim away more of that. I'm going to use this same pattern to dispatch also these z values. That way I don't have to go through the process of deconstructing again. I've got it right there. And now you just create a curve at these points that are representative of those z values. Obviously, I don't want circles to have a radius of 160 based off of its height, so I got to remap those values. So again, I'm just going to look at where those what the highest value I could have for this to just help me out before I have overlap. So I can see I can probably get to about 0.5 and be okay. So that's good. So let's remap these values. I'm going to drag this into here. I need to find that domain using the minimum, maximum, or the bounds component. Then I'm just going to construct my own domain. I'm going to say 0.05 is my lowest radius. And then 0.5 is my highest. And now that becomes my radius. So if I were to look at it from the top, you can see it's starting to achieve that. So that makes sense, right? We have all our high values there. We can then do the same thing with our colors. So I'm going to convert these to surfaces. By using this boundary component. And I'm going to use those same values to create a color gradient. Again, it doesn't matter what these values are, they're all going to be reinterpolated. So as long as the highs are still meaning high and lows are lows, we're okay. So we can see our low value is going to be probably, we could mess around with this. So maybe it's still kind of a low, but it reads more whitish. And then this one just reads as a more kind of vibrant color. That's a little, let's have a little more contrast. Now I'll turn all that stuff off and voila. So now we can so it's pretty dramatic, but that's okay. We can always change that too. So, I mean, that's pretty funky and crazy looking, right? So we can always like rescale or move these so that it's not like a ridiculous axon. So I'm just going to go ahead and move these. And the Z, or no, we don't want to move. We want to actually, this will be good. We got to project them down to the ground. Find the point of each one of these, measure, so we'll do distance from this one to this one. And then we'll, whatever that distance is, multiply it by a fraction. So let's just try and do 0.5. Move these ones, let's move the ones at the bottom up based off of those values. So we're just moving those ones in the bottom, but then we're just using the distance between the high and the low and just giving it a fraction. So half that distance. So you can see now that's much more reasonable. If we want to continue to do that, we can just change this slider. So that looks a little bit more tangible. That's pretty cool, this, so. Okay, easy as pie. Something that would be good too, one last thing. So we got like a couple more minutes. I would also do in QGIS, you can do an actual real elevation or real height field. So you have that elevation one that you can pull. And you can also do the same thing where you give it that gray value. So there's 25 height values. We can do inverted. So again, it's actually reading correctly. Hit OK. And then let's refresh this bad boy. So this we can actually create like a regional elevation map. Let's just do that at 200. And now we're just going to go back to Rhino. We've got, I think, that rectangle in there still somewhere, right? So let's do height field one more time. Let's wait for this to finish up. There it is. Again, we'll change or scale it to be correct. So it's still 42 by 42. Let's just do 25. Ooh, that's still way too high. So we can just turn our gumball on in order to That's would have expected there to be not so much of a plateau, but we can go over that at another time. But the idea is you can start to kind of create this axon that overlays with your, so you can start to have it hover like that. Then you can play with like the Photoshop to even like fade this so it actually does fade into the background. So I would just go to File. Yeah, that's a really terrible boundary or height field. There's definitely more height change in that, but I'm just going to take a big old black brush. What's good is that this should just update. Saving, come on. Then I go back to Rhino. See, now it's got the feathered edges, so you don't really have like that hard background or outline. Even though it's still there, it's just a different texture that's been mapped on it. Yeah, that should definitely have a lot more undulations, but something worth to try. Yeah. Got to figure it out. Huh? Say that again? So once you go through that process, you should be able to like bring in those other images for the height fields. So you'll just manually in Rhino do height fields, bring in those surfaces, and then you'll just reference multiple surfaces, and then you can go through that set component to kind of cycle through them. So if you have multiple surfaces in here and you do set, list item, and however many you have, you just make a number slider. So like 0 to 10 if you have that many objects, and then you just cycle through this. It'll go, so here's the first surface you reference, or like 2002, 2003, 4, 5, and it'll just shuffle through those different surfaces. Yeah, because they're all just gonna, you're gonna then plug this into that one. And that's gonna, just think about this real quick. And now it's all operating off of your collection of surfaces that you'll have here. And everything's just gonna respond from it. Yeah. Mm-hmm. Exactly. Yeah. Yeah. Obviously, if you guys are struggling with it, you can always come in and we can go through it too. So. What's up? Well, the video doesn't technically have to be due Monday. But get the static parts. Yeah. So this could, like what I was saying, like this could be your snapshot of that placeholder, right? So try and find, like, obviously it'd be good to see like where the state boundaries are, so you can bring in the vector of those state boundary lines and just like project them onto this so you can see it. You can include those water bodies. All that stuff can come in as well. Yeah. Have fun. Datascapes. Go round. Yes.